So this was a good question given to us by Neil about wanting to just say he wanted to commercialize a human-powered vehicle, and he gave us this rough sketch, and he wrote us this novel, which you can read there. But the basic gist of Neil's question is, how do you combine both styling with your T-spline with needing to hit exact shapes? And specifically with the two presenters we have on the line today, we've done a number of webinars with Kyle where he's cared a lot about style and just caring that the model looks good. And then Sky's done some webinars for us where he's really focused on exact modeling with T-splines. But what if you have to put both of those together? And so Neil's mentioned as he's tried different techniques, the more topology he adds, the more details he adds, sometimes he gets frustrated because then it's harder to refine different parts of the model. So we want to talk to this and get some insight from both Kyle and Sky about how you create a more complex model that has both nice style and also hits precise dimensions.
This is actually a kind of a great example, and I'm particularly interested in working on this one with Sky because he and I approach things entirely differently. I'm a bit of a find the way along the way kind of guy, and Sky is much more analytical and precise about the way he does things. So we actually have a little micro simulation of a design and engineering workflow between the two of us that in the next 15 minutes we'll try and show you the history of the world here on how this would go down. But so basically what my approach on how I would do this is I would
the button masher approach, right?
Yes, this is the gorilla in a grocery store kind of approach. You know, I would start with something like this, and we take a sketch, and the very first thing that I would try and do is I would try and lay out just something very basic as far as, you know, a sketch of what this thing is going to look like. And I basically do this when I do projects because I'm trying to just save myself the time of trying to hunt around with this in CAD because it's really easy to do it here. And by the way, this is Sketchbook Pro, which is also an Autodesk product. And if you're still sketching in Photoshop and not Sketchbook Pro, you should punch yourself resoundingly in the face because this, as far as a sketch tool, is so much better than Photoshop, it's not even funny. And they're not paying me to say that. I just use it and I like it, and I think that everybody should kind of be into this, using the best tools possible. So I'm just going to come in here and just scrub out a shape really quickly. And while I'm doing this, I'm going to kind of look at this thing and try to identify what I'm going to be looking at. Specifically, there's this rub strip here, there's a little jog here, there's some sort of crazy headlight thing going on, and then we've got a cut for the windshield. So I'm going to try and just block that stuff out, basically kind of think about where it's going to be and what it's going to do, and then I'm going to just call it done, and I'm going to save this out just as a JPEG. And
because I love this question. Like, this is such a great example because there's, like, you know, really like the marrying of the two separate things. Like, it's a human-powered vehicle. The user wants to maintain some sort of aerodynamic fidelity to an airfoil, which is very important in something like a human-powered vehicle. But at the same time, we've got to do, you know, style to it and really put something, you know, that looks nice.
Right.
And so this is really, I think, where T-Splines shines for certain things, and we'll go through and sort of say, like, this is the T-spline thing, and this is where we would actually go and use standard nerves. But it's such a great example because it really just, like, it's all it's everything that you would want all rolled up in one.
Yeah. So what I'm doing here is just I'm just bringing this sketch in as a picture frame, and you get to see how tilted my wrist is here. And I'm just going to drop this into this. I'm just going to drop this into the modeling window and use it as a reference in the background. And if you haven't done this before, this is just the picture frame command. It brings in a plane with the image mapped onto it. If you click onto it, you can go over and change the transparency and all that stuff and drop it out. Very useful. It also shows up in the perspective view. So I use picture frame. Anybody who's still using background bitmap may want to reevaluate your life choices because picture frame's way better.
I would agree with that.
So let's talk about how to lay this thing out. And the very first thing that I'm going to try and do is I've got an arc here. I've got a reversing arc here. Now arcs, right, are 3 points. The simplest way to describe an arc is with 3 points. Keep in mind that there's a correspondence between how you lay out curves and nerves and how you lay out patches and T-splines. If I take and I go up here to my append face workflow, and if I lay out a single face in here, and I bring up this, and I bring up my object, and I go to edges, and I alt drag, shut the Rhino gumball off, shut the smart track off, and I just alt drag. I'm going to do this in box mode. I can put 1, 2, 3 points there, right? And ideally, I may even want to do this because, right, simple, simple, simple. We want to start as simple as we can and then add only where we need to and when we need to. So if I smooth this out, you'll notice that I get a nice arc, right? See, 1, 2, 3. That's all I need in order to get that shape. I don't need 10 because if I have 10, what's going to happen? I'm going to put all these inflections in here. Let the computer do the math for you. I'm going to now reverse that curve by coming over here. Again, 1, 2, 3, so I'm describing an arc that way. And then I'm going to probably put one more there and one more here. Quickly point edit this. And that is the basic paper doll, right? You guys have seen me do this a million times. It's paper doll workflow kind of laid out. Now we want to start getting our shapes in here. Well, I know this thing needs to start wrapping over, so I need to bend it in this direction, right? Well, I can't bend it if I've only got 2 points. I need a third point in order to make my arc. So I'm going to just grab one of these, hit the K key, which is going to open, which is going to select all of my vertical edges, and I'm just going to insert an edge. I'm just going to drag it in here somewhere like about where I think this thing is going to start breaking over. And in this case, it's going to be probably about there. And it's not going to be an exact translation, so I'm going to actually just come in here really quickly and just point edit these up a little bit. And you can see how you can start laying this thing out where it starts making sense. I'm starting to pick up my arc back here. I can pick up this edge. And let's start adding some form to this. All right, if I smooth that, you see, because I've stayed nice and simple, I'm getting really, really, really nice curves out of this. So at this point, what I can do is I could thicken it and I could start adding some shapes to that. But let's get this little bump out on the side. Let's talk about that a little bit. This little fender shape going on in here. Now there's two ways I can do that. I can do it like Sky was talking about, where we actually add a fender, and the way to do that would be to grab these faces and delete them, and then grab these edges and extrude them. Okay? Now you can see this is starting to develop into a fender. And then to complete this, I'm just going to go 1, 2, 3, so that these all line up. And I'm going to weld, 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 and I've got my fender shape. All right, now I want to do as much with this as I possibly can. I don't want to add detail that I don't need. So, and anytime you add topology, I use the make uniform command here. Sky and I actually were talking about this last night. That should just actually be a default reaction to any time you add detail to this. So let's pull this out. I'm going to exaggerate this a little bit because I'm an exaggerator. And
yeah, you are.
Some say liar. I say exaggerator. And we're going to start developing this. And you can see our highlights are starting to sweeten up here. So at this point, we want to try and add some shape to this. And there's a couple ways we can do that. I'm going to alt drag out a row of faces up here. And that's going to wrap me around the corner there. Let's add some symmetry to it. Symmetry's fun. Let's do that. I'm going to move this whole thing to the center line, grab this edge, and I'm going to snap it to the Y at 0. Using Peter Harris is great. Plug-in tools. If you don't use those, go to the McNeil Wiki and pick them up. Peter Harris tools. Okay, I'm going to apply symmetry to this. I'm going to add it. It's going to be axial. It's going to start here, go to there. It's going to weld up. And as you see, I have a nice green line everywhere except on the back. Well, the back doesn't have a nice green line because it's not touching. So let's airfoil this thing out a little bit. And actually, yeah, I'll grab both sides because I want to scale to the center. Sky, I was expecting a lot more mocking while I was doing that.
Oh, yeah, airfoil this out is definitely
I'm a little disappointed with the lack of mocking that I'm from you.
I mean, what I would add to this, though, is that this is sort of the way that I would think about what Kyle's doing right now is essentially like a topology study. You have to think about what your features are and how you want to express those features. And then once you've figured out, because what you want to know is like where are your star points, how are you going to sort of put this thing together, what is your topology going to look like, and then you can start to figure out like, okay, well, how do I build this like actually with like a real airfoil? How do I make this accurate? You know, how do I put accuracy into this thing so that I can maintain some sort of fidelity to a shape, right?
Yeah. Yeah. So where I'm at right now, let's go back to the front view real quick and let's take a look at our sketch. Let's just say for sake of argument that we've got this laid out and it's the way that we want it. Now, one of the elements that this designer was talking about was this rub strip on here. And this is something that trips up a lot of people in the fact that they get hung up on, I've got a model, everything in T-Splines. Well, in this case you can, but maybe not in the way that you were originally thinking.
Yeah.
So instead of trying to, let's say, split this and extrude and add this in and I'll have it be one T-spline, I know that I want this rub strip to come in here and wrap up over my rear fender. Well, I've got a nice ring of faces around there already, right? So I'm going to go ahead and just select all of those like that. And I've got a row of edges around there. Well, what if I just were to duplicate those off and look at just that? Let me see if I can hide this for now. All right, so let's just look at this for the time being. Well, what can I do with that? I can add an edge here to get this to be thinner, right? And then I can pick these faces up here and delete them, and now I've got a little thin strip, right? Well, what else can I do with this? I can pick this and I can thicken it, right? So I'm going to just thicken it inward a little bit, and I'm going to bring everything else back. And look, I've got what's the basis of my rub strip. Now, the cool thing about thinking about it this way is you can now go and edit this and get it just the way you want it without being constrained by the underlying topology, which is one of the problems, right? Let's not call it a problem. Let's call it one of the benefits of T-Splines is the topology. However, sometimes the topology can get in the way if you want to do something where you don't have topology. Well, if you have a situation like that, it's as simple as just adding some new bits, and then you can always go back, convert the stuff to NURBS, and then Boolean it together. Why force yourself, you know, you've heard me say this in the past, but why force yourself to pound in screws with a hammer when you can use it for what it does really, really well and not worry too much about how it's going to lay out. Now, there's a start point right here. If I was trying to build topology through here, this start point is something that I'm always going to have to keep in the back of my mind. Whereas if I just bust this off and use it however I want, I can do stuff like this. It's completely unrelated to the underlying topology, and then go back at a later date and merge that in. So you've got the freedom to design this however you want just by using your underlying data to create new pieces of data that you can use then to combine into something that would be difficult to do any other way.
Yeah, and
let me show you a quick example of this, and then I'm going to kick it over to Sky.
Yeah, and just to cut in, as we were talking about this webinar and lessons that we wanted to have as a takeaway, I think this was the main lesson that both you and Sky had in mind, is that when you were first came in contact with T-Splines, there's a possibility to model everything in the entire model as a single unified T-spline. Yep. And you don't have to do it that way. You need to be in, right. You just think about the purposes for why you would want the whole model to be together versus benefits that come from having it be in pieces. And I love this example that you have right here to show that.
Yeah. Totally, because I've been guilty of that in the past, of you know, doing things like sort of overcomplicating a T-spline model.
Oh, do you have a great example of that?
I'll show you my dirty laundry in a bit. But this is really like this is really the direction that my workflow has been going into, and I feel like Kyle and I have sort of been like meeting in the middle on these types of things. Where it's really about using the T-spline in its most sort of powerful, direct, basic sense, and then trying not to like muck it up by making it so overly complicated. And a lot of what this question talked about was that. Now, I will say that Kyle's example for this HPD body doesn't conform to any sort of specific airfoil. But what I'm going to show you once you kick it over to me is a different way to approach it that will add that accuracy in.
Yes. And ideally what would happen is you'd have some nutty designer in an office somewhere, right? And they'd be flicking curves at the universe, and they'd get something that you want. You'd go over to the engineer, and and between the designer and the engineer, you would then take that, you know, ridiculous kind of pie in the sky shape and refine it down to something that could actually be useful and beautiful at the same time. This is a really quick example, and then I'm going to kick it over to Sky because I'm monopolizing the time here. But if you look at this, little model, and basically what this thing was, this is a toy model. I work in the toy industry. I do this stuff all the time. It is a collection of T-Splines parts with some NURBS parts, and I use T-Splines for what T-Splines does great, and I use NURBS for what NURBS does great, and when you put them together, you end up with something that's way better than you would have had if you would have tried to build it all by itself. Like this transition right here, and I'm an admitted highlight nerd, but this transition right here, stuff like this is really difficult to model in NURBS. In T-Splines, it's literally just pull a few points and you're done. So I modeled the entire fuselage. I modeled this little trim piece. I modeled the wings. I modeled the front wings. I modeled the cockpit surround, the windshield, this little cowling right here, and this. I also modeled the suspension components, but they're all separate pieces. Now, the cockpit surround and the windshield, I did the same way that we did on that HPV, where I actually selected some pieces, duplicated them. If I were to be able to blow this apart, you could just get the hint of what this ring looked like around here. So I duplicated this ring, brought it off, thickened it, mushed it around until I got it the way I wanted it, and at the end I converted the entire thing to NURBS and put it together. Now, one additional benefit that a lot of people don't think about when they use T-Splines is the fact that it will offset. So when you're doing parts that you need wall thickness, do your wall thickness in T-Splines first, then convert to NURBS, and then use things like wire cut and booleans and stuff like that in order to get your bosses and all that kind of stuff. But instead of trying to build this thing, convert it to NURBS, and then shell it, you can put your wall thickness and everything in it right off the bat to end up with something that that you wouldn't have been able to model any other way.
Yep.
So that's kind of what I wanted to show here. Let me boot this back over to Sky, and he can show you how to take my mindless ramblings and turn it into something that actually is usable.
So Kyle, as you're switching over to Sky, there's just a question that came in. How long did that take you to build that plane?
Day and a half.
Day and a half?
Yep. So about 10 hours.
Gotcha.
Why so
And
slow?
there was some changes and stuff that came in, which it probably could have been done, in a single session, which for me, my butt and back start to fail at about 8 hours of sitting in a chair. So usually about 8 hours is what I consider a session. But without having to go back and readjust stuff, it was probably 10 hours start to finish.
Okay, so the approach that Kyle took with that strip approach, the way that I would take that, as I said, is like almost like a topology study. So you can figure out, like, once you add your accuracy in, what your model is going to look like, what you're going to do with it. And so what I've done is I've taken an airfoil, and so what I did was I created this. This is actually based on an actual NACA airfoil. And I made with as few control points as possible. In this case, it's like 8 segments per side, 8 edges per side to make this. And there's a lot of stuff, if you go back and you look at the advanced modeling webinar that I did that talks about sort of figuring out like how to build something like this. So for the HPV guy, I would really recommend you go back and look at that. But so if you want to start with an airfoil, one way to think about this HPV is it's basically like a wingtip that's been rotated vertically. So this is really going to look like any other wingtip that you would make. And so let me start by taking this and extruding it. And then to build that sort of top arch that we have and the recurve, what I would do is you need to kind of close this thing off topologically. And so I would take just one side here, and I would extrude this, and then I would weld this whole thing back together. To there, and this will just take a moment. We're just going to run down the line here and weld this together. And so what we have is we know we have something that has some fidelity to the airfoil cross-section that we're looking for. And I guess the best thing that I could say is to be super realistic about what that fidelity needs to be, right? Like don't think that you need thousandths of an inch of fidelity to the airfoil. Believe me, you don't. And now what we can do now that we've got this airfoil shape here, you realize like, oh yeah, this is a wingtip. And what we can do, it helps if I grab this edge as well, is just start to pull on these verts here. Oh geez, what's going on? There we go. That's what's going on. And oh haha, making me look bad. Let's see if we can get this to behave. There we go. Okay. So you can start to grab these verts to create this roof line that Kyle has. Now, you may also think about how much control that you want along this line here. Now, the way that I have this set up, I don't have any lines or any verts running along here. And looking at it, when I switch this into smooth mode, I realize like, I probably want that, right? Like there's not quite enough control along here to control sort of the arch shape of that ridge line. Let me show you a really kind of quick and easy way to do it. What we've got right now is our star point is right here. That's what's sort of closing off the top of this box, really. I'm going to show you a way to actually move that star point. And so I'm going to delete those forward two faces. I'm going to insert an edge here. I'm going to extrude this back up. I'm going to weld it here and here. And now I've got this four-sided face here, and I'm going to fill it. And that's the kind of thing that this is the kind of thing that I'm good at, and I think, Kyle, this might drive you insane, right?
I'm literally punching myself in the face right now watching you do this.
So now, what I've done, if you remember before, my star point was here. I've just shifted my star point here. And in fact, I could shift my star point here, or shift it here. It's really just a matter of sort of repeating that trick of adding edges along here. And so now I've got something where I can start to control the sort of arch shape of this front here. And we're still maintaining the fidelity of this overall airfoil shape. And then to sort of go back to where Kyle was with all this, we can also just bump this out. And I'm going to delete these back here. Bring this back in here. Oh, what went wrong? That's what went wrong. Maybe? What's going wrong with you?
Scott, you could also match that center line to a you know, that center line. You could drop a curve in there and match that, and with a really precise center line if you wanted to do that. Since you know you're Mr. Precision and all.
Right. Yes. There we go. Okay, so now we've got something that we've got the same topology of what Kyle had, and we can start to think about maintaining that airfoil shape here, especially at the front end where it's most important. And so that really kind of like splits the difference. Like that's sort of like the two different ways, really diametrically opposed to achieve this. But you need to sort of understand both approaches in order to get what you want. And in terms of what we were talking about, saying doing it wrong or sort of doing it all as one, let me show you what I would not recommend doing. This is a Porsche 962 model, and I took some laser scanned data from a little Tamiya kit cart, and I built this just to see if I could as one T-spline. So this whole thing is one T-spline surface. And
we want to put a big disclaimer out here that this is not what you want to do.
yeah.
This this was Sky taking a moonshot here to see whether it could be done, and I personally give him a standing ovation for being able to pull this off, and then slap him in the ear for wasting his time doing it this way.
Yeah, well, I mean, to clarify though, there are good parts to this model, right? And so maybe we could point out the parts that are well done, and maybe the parts that you'd want to do a different way in the future.
I can definitely expound on that. There's certain parts of this that are appropriate uses of T-Splines, and certain parts that are just silly, right? So, like these, in this particular case, the sides of these cars are really flat. So, do we really need to cut in the wheel arches here with T-Splines? No. We could have left this as a T-Spline totally closed off, come in with NURBS and just trim the hole in it, and then just blended sort of this return in here. There's, like, this shape is so simple, there's no point to that. But the things that are, okay, so here's another thing, like, why are you doing this with T-Splines? These window, these sort of window piping, these brake lines, these panel line brakes, really, I mean, I look at that and I was like, why did I hate myself? The spoiler here, not really much point in making the spoiler part of the overall T-Spline. In fact, let's call that totally silly. But the things that are really good, frankly, like doing this vent here, that comes in here while this comes around here. This is all stuff that I wouldn't want to do in NURBS. This sort of valley in here where it comes up to the cockpit, this is all stuff that I love T-Splines for. And while there was no point in doing this sort of, you know, return for the windshield here that I did, at the same time, the overall approach to doing this sort of whole cabin as one T-Spline is totally legit, and I would completely recommend it. So this is like an interesting mix of like things that I would now still use T-Splines for, and things that I would absolutely not recommend using it for.
Yeah.
So
yeah,
I think that's about all I got to say about this.
Beautiful model, though.
Yeah, the model's absolutely gorgeous. The only other comment that I would make is if you start getting into the point where you have this many ISO curves on a T-Splines model, you may be wandering into Sky Greenawalt moonshot model territory.
Right, just stop. Just stop.
and I don't want to come across like I'm bagging on this model, because it really is an artistic and technological masterpiece. But typically, if you start seeing this many ISO curves on a model, you need to stop and back away from the keyboard.
Right, because so like one of the questions on the HPV was like about like creating the split lines, and this goes to that like rub rail that Kyle was talking about. The shape of this window here is dependent on the T-Splines topology. There is no good reason for that, right? Like you could just come in here and you could project a curve of your window shape onto your T-Spline and use the pipe function to create the exact same idea with a tenth of the heartache, right? So all those sort of splits. There was also a question about the vents in the front of the HPV. And like, so there's a whole bunch of little vents that are arrayed up here. Again, just do those in NURBS. Like those are perfectly great things to do in NURBS and to sort of cut in later, and think about those as like a secondary operation.
Yeah.
So Sky, how you think
Sky,
about...
there's a request to hide the ISOs on that Porsche model.
On which one?
Hide the ISOs on the Porsche model, just so everybody can appreciate the ridiculous awesomeness of that part.
Okay. There you go.
There you go. Enjoy. There's some CAD porn for you.
So Sky, as far as how you approach modeling with T-Splines today, then is it fair to say that you would consider, as a general rule of thumb, using T-Splines for the primary surfaces and then more of the secondary surfaces transitioning into NURBS for those?
Absolutely. I mean, I would completely agree with that. Yeah, like because the T-Splines are so good for those big macro shapes, and if you keep that T-Spline nice and simple, then you've got it nice and editable. Your life is much, much easier. And then really the approach that Kyle has, like on that toy plane, is so perfect. It's like for all of your detail work, for all the secondary stuff, use T-Splines, use NURBS, use, by hook or by crook, whatever you got to do to get it done. But just because you can do the whole thing as one integrated T-Spline doesn't mean that that's actually always the same reasonable, well thought way of doing it, right?
Yep.
Like, it should be a mix, really.
Right. And to be fair, and again, this model's ridiculous how good it is. However, if you want to get really super nitpicky, if you notice the highlight tracking through the door on the side,
it's wrong.
It's not as good as it would have been
Totally.
if you had built it without the cut lines in it, and then put the cut line on. That highlight would track correctly with it. So, and this is and again, I don't want to sound like I'm bagging on this because this model's amazing, but there is a real tendency when you start trying to do this stuff, especially in hands that are not as experienced as Sky, that you will make an unholy nightmare out of trying to do this by adding topology into this. So,
this window is real baby with the bathwater right here. This is like,
that's where it starts to kind of all go pear-shaped.
Yeah, I agree. I could not agree more. I would not do it this way now.
And I keep picking on it because I'm really jealous that you did it. It's a really good model.
Okay. Well, let's. We're a little bit over the time we targeted for the webinar, but I would. Sky and Kyle, do you guys have a couple more minutes just to trim through a few questions?